In this video we're going to look at the slope of a line and also what the equation of a straight line can be, different forms of the equation of a straight line. Now this should be a reminder for most people, I think, but the slope of a line is just how much a line goes up by divided by how much it goes across by. So this line here has a slope of 1 because it goes up by 3 and it goes across by 3. So it's 3 divided by 1. This line over here, notice that the slope is negative because it goes down to the right. So it's going down by 3 and across by 1. 3 divided by 1 is 3, but since it's going down, it's negative 3. And there's an equation for it, which I'm sure that you're aware of. If you want to find the slope of a line, it's rise over run. Or you can think of it as being the change in the y-coordinates divided by the change in the x-coordinates. If you look at this line here, you can see that the y started off at 1 and became 3. So you have to do 3 minus 1 to figure out how much that line has gone up by. 3 minus 1 you can see over here. And also from here across to here, from 2 across to 4, that's how much the x has increased by. So you have to do 4 minus 2. And you can see the 4 minus 2 in the bottom to get the change in x. And so 3 minus 1 divided by 4 minus 2, that gives you 1. This line has a slope of 1. So in this example down here, if you're going from a being negative 2, 1 to b being 3, negative 6, you on the top just have to, if you imagine that this is the new point, this one here, you would take the negative 6 to be your y new, and the 1 would be your y old. So if we do that, we can substitute in like this. Notice what we've got. We've got the negative 6 minus 1 on top. On the bottom, again, it's the new x. We think of this as the new point, point B. It's 3 minus negative 2. 3 minus negative 2. And if we do that calculation, what we should get is negative 7 over 5. And that's our slope. If you have a horizontal line, it isn't going up at all. The y is staying the same, so the slope of a horizontal line is m equals 0. M is the usual letter that we use for slope. Now, something else that you probably are familiar with is this equation here, y equals mx plus b. All it is, the m is the slope and the b is where it goes through the y-axis. So, if we look at this example here, we're told that a line has a slope of 1/2 and it goes through this point. This point, incidentally, 0, negative 3, is on the y-axis. It is the y-intercept. So, if you're going to write the equation of that, we know what the slope is, right? And we know what the intercept is. Right? The intercept is going to tell us that b is equal to negative 3. We also know that the slope is 1/2, and so we end up with the equation of y equals 1/2 x minus 3. Notice that minus 3 is where it goes through the y-axis. The half is the slope, and that's all there is to it. And this is called the slope-intercept form of a line because we have the slope in it and we have the y-intercept here. In this example, example 3, we have to try to figure out what the slope and the y-intercept are. Now what we've got to do is to rearrange this equation, right? Rearrange this equation here so that it says y equals and then blah blah blah. So let's isolate y. We'll have y on the left hand side and we'll make it equal to something. Okay, so we make y the subject. Our job then is to subtract 3x from both sides. So we have 2y equal to negative 3x plus 4. Once we've done that, we can divide both sides by 2 and we get this. Y equals negative 3/2 x plus 2. Now if you look at that, the negative 3/2 is the slope and the 2 is where it goes through the y-axis. It has a slope, it's had a slope of negative 3/2 and it has a y-intercept of 2. And you can actually see that over here on this graph. You can see that this line goes through the y-axis at 2. Right? This 2 here tells you where it goes through the y-axis. The negative 3/2 tells you that every time you go across by 2, you have to go down by 3. This line has a slope of negative 3/2. If you start at this point and go to this point, right, you're going down 3 and you're going across 2. 3 divided by 2. But of course it's negative because you're going down to the right. Now, the slope-intercept form is not the only form of the equation of a straight line. There's also the point-slope form of the equation. And this is useful when you're told what the slope is, you're given what the slope is, and you're also given a point somewhere on the line. The point is thought of as being x1, y1, this point here. The equation just looks like this. It's y minus the y-coordinate of the point that you're given equals m, the slope, times, in brackets, x minus the x-coordinate of the point that you're given. So in this example here, there's a line with a slope of 1/2 going through this point, 1, 2. So this 1 is going to be in place of the x1. It's the x-coordinate of your point, and the 2 is going to be in place of the y1. The 2 is in place of the y1. So substituting those in gives us this equation here. Simple as that. And this is the point-slope form of that equation. Sometimes we can leave it like it is just now. Sometimes we need to rearrange it. And finally, for this video, we're going to just look at one last form of the equation of a straight line. It's this form down here, sometimes known as the general form. But before we get there, there's one example we need to do. If you want to find the equation of a line and you're not given the slope, all that you're given is 2 points, negative 2, 3 and 5, 4 for example, you actually have to figure out what the slope is. So in this example, first of all, we figured out what the slope is. It's going to be just like this. You do 4 minus 3 divided by 5 minus negative 2. And that gives us a slope. Once you've done that calculation, on the top it's going to be 1, and on the bottom it's going to be 7. Now you know that the slope of the line is 1/7, so we can now use the point-slope form of the line. Now in this case here, we've got the 1/7, which is our m. We do y minus the y-coordinate of a point on the line equals m times x minus the x-coordinate that's on the line. So we've used this point to get this equation here. You could equally well use this equation. You could find this equation here by using this point. If you use this point, using the point slope formula that you got on the last page, the 4 is the y coordinate. Remember, it was y minus y1, so that's your y1 right here, equals m times, in brackets, x minus x1. The x1 is the 5 in this example. And if we simplified this, we would end up with the same equation, so it doesn't make any difference. If you have an example like example 6, if you're just asked for the slope, it's another case of just having to rearrange the equation until you get an equation that's y equals mx plus b. So it's actually very simple. In this example here, all we have to do is rearrange this a little bit. So shift the x and the 8 over to the other side. When you do that, you get this, and then divide by 3. When you divide by 3, you get this. Looking at this, you can see what the slope is. The slope is the number multiplying the x. It's negative 2/3. So the slope is negative 2/3.